Question 6, question about reactions of calcium compounds. Pure solid is thought to be calcium hydroxide. The solid can be identified from its relative formula mass. The relative formula mass can be determined experimentally by reacting a measured mass of the pure solid with excess of hydrochloric acid. The equation for the reaction is that unreacted acid can then be determined by titration of the standard sodium hydroxide solution. You provide with 50 centimeters cubed of 0.2 moles per dm minus cube of hydrochloric acid. Outline given brief practical details how you conduct an accurate experiment to calculate relative formula mass of the solid using this method. 8 marks. I don't think I've ever seen an 8 marker before. This is the first time I've ever seen it. But same as a 6 marker. 3 stages. So stage 1. Well, the acid must be in excess. There must be an excess of acid. Well, it says the excess of hydrochloric acid. Now we can find out the moles of acid. 50 times by 0.200. 50 divided by 1000 times by 0.200. 0.01 moles. Using the equation moles equal to concentration and volume, and dividing centimeters cubed by 1000 because we want it moles per dm minus cube. So 0.01 moles. Okay. And we know that 2 moles of acid reacts with 1 mole of calcium hydroxide. Type that down. 2 moles of acid reacts with 1 mole of calcium hydroxide. Hence, moles of solid weighed out must be less than the half moles of half of the mole of acid, which is what? Well, it's just going to be 0.01 times by 0.05 times by half, which will give me 5.00 times by 10 to the power minus 3 moles. And I could rewrite this one as 1 times by 10 to the power minus 2 moles. Let's do that. 1.00. Okay, so the mass of solid must be less than this. Mass of solid. And okay, mass of solid must be less than this, well, moles is mass over mR, times by the mR, which is going to be what? The mass, the mR, which is going to be 74.1. That will give me the mass of solid must be less than 0.371 grams. Stage 2, experimental method. Measure out 50 centimeters cubed of acid using a pipette and add the weighed amount of solid in a conical flask. Titrate against 0.100 mole per dm minus cubed of NaOH, added from not from a conical flask, from a burette, because therefore it's going to have a high percentage of uncertainty, it's going to have a low percentage of uncertainty. But if you use a conical flask, a larger percentage of uncertainty. And record the volume added when an added